Today's lesson is on rotations. After today, you will be able to understand that a two-dimensional figure is congruent to another if the second can be obtained from the first by a sequence of rotations. You will also be able to describe the effect of rotations on two-dimensional figures using coordinates. First, we're going to look at our key idea. A rotation or turn is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure rotates is the angle of rotation. In a rotation, the original figure and its image are congruent. For our first example, we're identifying a rotation. You must rotate the puzzle piece 270 degrees clockwise about point P to fit it into a puzzle. Which piece fits in the puzzle as shown? Our puzzle piece is right here. So now if we're going to rotate that, if we rotate it 90 degrees, we would have this puzzle piece. And then we rotate it another 90 degrees for a total of 180 degrees. Our puzzle piece would look like this. And another 90 degrees would make 270 degrees, and then this would be our puzzle piece. This looks the same as choice C. So our answer is C. For our second example, rotating a figure. The vertices of a trapezoid are W is at -4, 2, X is at -3, 4, Y is at -1, 4, and Z is at -1, 2. Rotate the trapezoid 180 degrees about the origin, and the origin is 0, 0. What are the coordinates of the image? For our study tip, a 180 degree clockwise rotation and a 180 degree counterclockwise rotation have the same image. So you do not need to specify direction when rotating a figure 180 degrees. The first thing we need to do is we need to draw WXYZ. So we have this one drawn, and now we need to rotate it 180 degrees. It tells us to plot Z prime so that the segment OZ and segment OZ prime are congruent and form a 180 degree angle. Then we'll use a similar method to plot points W prime, X prime, and Y prime, and then we'll connect the vertices. You'll notice that Z is at -1, 2, and Z prime is at 1, -2. W is at -4, 2, and W prime is at 4, -2. X is at -3, 4, and X prime is at 3, -4. And then Y is at -1, 4, and Y prime is at 1, -4. The coordinates of the image are W prime is at 4, -2, X prime is at 3, -4, Y prime is at 1, -4, and Z prime is at 1, -2. For our third example, we're rotating a figure. The vertices of a triangle are J is at 1, 2, K is at 4, 2, and L is at 1, -3. Rotate the triangle 90 degrees counterclockwise about vertex L. What are the coordinates of the image? For a common error, it says to be sure to pay attention to whether a rotation is clockwise or counterclockwise. And in this problem, it said it's a 90 degree counterclockwise rotation. So we first want to draw JKL. We want to do 90 degrees, so it's going to be 1/4 of a turn, and we want it to be counterclockwise. L is going to stay in the same place because we're doing it about vertex L. So then we're going to take J and rotate it down, and so J prime would then be at -4, -3. And then K, when it rotates down, we're going to have K would be at -4, 0. It tells us here to plot K prime so that segment KL and segment K'L' are congruent and form a 90-degree angle. We want to use a similar method to plot point J', and then we'll connect the vertices. The coordinates of the image are J' is at -4, -3, K' is at -4, 0, and L' would be at 1, -3.